All right, so if you missed my live feed earlier, this is just what we talked about. All right, so I'm going to work through the review guide. That does not mean you don't get to post a discussion board. You got to do that. I can't give you any kind of grade if you don't do any work. So please make sure that you're doing that. So we're going to take 500 and we're going to plug it in for P. So 500 and we're going to plug it in for P. E is going to be that 2.718. Okay, it's kind of like pi. It's got a number associated to it. R is going to be that rate, so we're going to change that rate and change it to a decimal, so that's going to give me 0.0633, and we don't know T. It does tell us that we're going to double our money, so 500 times 2 would be doubling our money, so that's going to give me 1,000 over here. The first thing I want to do in order to solve for T is I'm going to divide by 500 on both sides. 2 equals e to the 0.0633 T. I'm going to take the ln of both sides, and the reason why I'm going to take the ln of both sides is to get rid of that e. So we're going to take ln, both sides, this cancels out, and that's going to give me 0.06 equals ln of 2. I'm going to divide by 0.0633 on both sides, and that's going to give me t equals, and if I plug this into my calculator, I'll get 10.95, and that's going to be in years. Now, if this was a multiple choice question, T would probably be 11 years. Would be the answer choice that I would go to. All right, number 2. It says the coins that Alexis has are dimes and quarters. That's going to be important. And her coins have a total value of 50 coins. We've got variables D and Q. And we're going to write in a system of equations. So the first equation that I'm going to write, well, I know that dimes have a value of 10 cents, which can be written as 0.1 D. And then quarters have 0.25 Q. And we have a total value of $5.80. So then for our other equation, we're going to have the number of dimes plus the number of quarters. And we're going to set because that's what the number of coins that we have are. I could use these to solve for Q or D, but it just tells me to write a system. 3, it says rewrite the equation to isolate D. Okay, so we're going to take this equation and we're going to rewrite it to isolate D. So we're trying to get D by itself. Okay, so we're trying to get D by itself. All right, so the first thing we want to do is subtract 3.5h from both sides. And that's going to give me T minus 3.5h equals 2.25D. I'm going to divide by 2.25 on both sides. And D is going to give us T minus 3.50h divided by 2.25. Now, this would probably be your answer, or you could divide these up into different fractions. Probably is just going to be written like this tomorrow, though. On number 4, we've got this equation D equals RT, and we're trying to rewrite and isolate it in terms of R. So we're trying to get R by itself. So R is attached to this T, so we're going to divide by both sides by T. So R is going to equal DT. I would highly suggest looking at this because 2 questions are very similar to this. Okay. Number 5, I've got this equation D equals 1/2 AT squared. I'm trying to solve for T. That means I'm trying to get T by itself. So first thing I want to do is get rid of this 1/2. In order to get rid of this 1/2, I'm going to multiply by 2 on both sides. So that'll cancel out that 1/2. I'll get AT squared equals 2D. I want to get A away from T, so I'm going to divide by A on both sides. And that's going to give me T squared equals 2D divided by A. T is still not by itself. It's got this squared. So in order to get rid of a square, we're going to take the square root of both sides. So my final answer is T is going to be equal to square root of 2D divided by A. All right. Again, if I'm going too fast, pause the video, go back, whatever you need to do. Number 6. Number 6 is where a lot of people start to struggle. So on number 6, we're going to identify the variable, write the objective function, and then identify constraints. Remember, constraints are kind of like restrictions on the objective function. I think in the video or in the live chat, we were talking about constraints being kind of like, you know, when your parents say, hey, you can spend your day however you want, but your bedtime is, 9 p.m. and then they wake you up at 7 a.m. So between the hours of 9 p.m. and 7 a.m., you can't be doing whatever you want. You actually have to be in bed. Okay, so that's kind of like a constraint on your time that you want to spend. So it tells us that you've got the shrimp and lobster. Shrimp costs $3.87 and lobster costs $7.47. And you have a budget of $120. Okay, so the first thing I can do is I know my variables are going to be X is going to be equal to the shrimp pounds, like pounds of shrimp. That's represented by LBS. And then Y is going to represent the lobster pounds, or the amount of lobster that I'm going to have, right? Okay. And then I can also go ahead and write my objective function because they already tell me all the information that I need to know in order to write an equation. So that's going to be 3.87 times X, because that's the cost of the shrimp, plus $7.47 per Y, because that's the lobster. And then that's going to be set equal to $120 because I only have $120 to spend. Now, constraints. It tells me in here you can purchase at least 10 kilograms of shrimp and at most 20 kilograms. So X is going to be in between 10 and 20. So you could write it like this, or you can say X is bigger than 10 and then X is less than 20, or you can write that as this compound. It doesn't matter. It just depends on how you want to write it. And then you've got this other constraint. They tell you that you've got lobster that is at least 4 kilograms and at most 14. So at least 4 kilograms and at most 14. Okay? So this is how you would write that, or if you wanted to write this as Y is bigger than 4 and Y is less than 14. Okay, so Y is going to be in between 4 and 14. That's what this is saying. Okay? All right, so on the next one, it tells us that you are walking and then riding a car. You're walking at 3 miles per hour, and you're riding in a car at 40, and you're covering a total distance of 50 miles per hour. So our variables are going to be X is going to represent, or W, doesn't matter what you assign it, is going to be the amount of time walking, so walking time. And then Y is going to represent the amount of time you ride in a car. Okay? And then it tells us that you're doing 3 miles per hour for walking, and then you've got 40 miles per hour for riding in a car, with a total of 50 miles per hour. And then they tell us constraints. And our constraints are 2 to 4 hours when you walk. So X is going to be in between 2 to 4 hours. Okay, and then you ride in a car for 30 minutes up to an hour. Now this 30 minutes, we've got to make sure that it has the same unit as the other one. So we have this 1 hour over here. So minutes and hours, those are two different units. We need to make sure that they're both in the same unit. So 30 minutes, well, that's half an hour, right? Because a whole hour is 60 minutes. So how do we represent 1/2 in decimal form? Well, we say 0.5 of an hour. So our car time is going to be between 0.5 and 1 hour. Okay. Number 7, compare the functions shown in the graph below. And so this is A, and then B is this equation right here. Okay, which function has the greatest maximum value? So we're looking at the Y values of this. So if I look at the Y value of A, it's roughly like 9 to like 9.5. Okay, if I take B and I plug it into my calculator, and tomorrow on your test, you can use Desmos, you can use a TI-83. There's a TI-83 download if you want. Just type it into Google, it's free. So if I type this into my calculator, and I highly suggest using the TI-83s just because it's going to be easier. If you've got an Android, yay, Androids, you can do Wabbit Emu. And if you need help on that, just let me know. And if I go to second graph, that'll pull up my table. And I'm going to look at my Y values. I'm trying to see if my Y values go above 9 to 9.5. And it totally does, because it goes all the way up to 32. So that means that B has a greater maximum than A. Okay. Number 8. It says, which function has the greatest root? Now, what does root mean? Root is x-intercepts, so where it crosses the x-axis. So it crosses at -0.5 And it also crosses at 5.5. Now, we're going to plot this equation in our graphing calculator, okay? Which it is different from the first one, so make sure you pay attention to that. There's something like that on the test, so be careful. Pay attention to your signs, please, okay? And if I actually graph this, I'm trying to see where it crosses the x-axis. So where does it cross? Well, can't really tell from that, but I know it's going to be on the positive side, okay? Well, x-intercepts, that's when y is 0, what is our x, right? Okay, so y is 0, what is our x? So when we look at this, y is 0, what's our x? X is 4, right? Okay, so that means that A, our graph, has a greater maximum, or x-intercept, than B, because B had that 4, and then A has that 5.5, okay? Number 9. Okay, so suppose Ben and Andy each throw a baseball in the air. Ben's height is represented by this function, and Andy's represented by this graph. Ben claims that his baseball went higher, and Andy says that his baseball went higher. Who is right? So this is kind of like saying, what is the maximum? Okay, so what we're going to do is we're going to look at Andy's maximum. Well, Andy's maximum is roughly around 75. Okay, we're looking at that y value. So you look at the y value right here, that's roughly 75. And then you're going to plot Ben into your graphing calculator. Okay, so we're going to come in here, that y equals, you're going to type, and I'm going to type a little bit faster because I'm running out of time, plus 6. Okay, so if I look at my table, we'll look at the y values, okay? So on this one, this is Ben. Ben's y values are definitely bigger than 75. Like, he's got 100. So then that means that Ben is right because his y values are bigger, okay? Or his maximum is bigger, right? Now, part B, it's asking how long each baseball was airborne. This is really like asking your x-intercepts. Okay, which one, like how far was it? So if we actually look at this one, okay, we see that Ben has an x-intercept roughly in between 5 and 6. And the reason why I know it's between 5 and 6 is because it goes for my y values 1 to negative 96. That means 0 is going to be in here somewhere, but it's going to be in between that 5 and 6 range. Well, for Andy, he only hits at 4.25. So it's only 4.25 seconds, right? So that means that Ben has his baseball longer in the air, okay? And because his x-intercept is bigger. Okay? Sorry about that handwriting. Number 10. Okay, so this is talking about transformations, okay? So you're comparing this to this function right here, okay? And you're telling me what the transformations that occurred. Okay, so what we can tell right now is if we go into our graphing calculator and we graph the function ln of x, okay? So compared to ln of x, this is the OG. What happened between here and here? Well, there definitely was a reflection across the x-axis, okay? That means that it flipped to the other side of this. And it also moved over. Well, it moved over 1, 2, 3, 4 units. It moved to the right 4 units, okay? And then it also moved up because it came off that x-axis, right? So it went up 3 units, okay? So these are the transformations that would occur. All right, last one. I've got 30 seconds. Write the resulting function when f of x equals absolute value of x. So if you're trying to put this function into your calculator, you're going to hit math. You're going to scroll to the right, and then you're going to hit ABS. Okay, if you're putting this in Desmos, you're going to hit shift, and then you're going to hit that backslash button, which is right above the enter button. So keep that in mind when you're graphing these. So this is what the OG function looks like, or the parent function. And then I'm about to put what the answer would be for this one. And this would be your final answer because this would be the reflection. This is moving 3 units to the right, and this is moving 4 units.